Okay, boys and girls, so today we're going to read the rest of the lesson. So I want you to watch the video from pages 38 to 42, the online textbook you can go to read it after we're done with the video. If you don't have that, what you could do is you could download the lesson or look at the lesson online. It's lesson.pdf. I would make it a little bit bigger so you could read the words better and read through it. You must read it. When you're done, watch the mineral properties identification video. If you click on the little view button, that's all you need to do next to it. You don't need to download it. And then finally, you have key concepts to do. Make sure you do that and make sure that you check the answers. And when you're done with that, then mark yes in the discussion board for homework. Don't do it in the discussion board for questions, just for homework. Just reply yes. Okay, so now we're going to talk about crystal structures. So minerals have a definite crystal structure to them. So the atoms line up in a regular pattern, and the pattern repeats. So crystals can be shaped all different depending on the atom structure or how the atoms line up. So like halite, which is what I marked right here, which is pretty cool. Halite looks like a cube, and when you break it, you will break it and hit it with a hammer. It will break off into tiny little cubes. So that's its crystal structure. Okay, next we're going to talk about cleavage and fracture. So cleavage and fracture is basically a mineral that splits easily along the flat surfaces, has cleavage to it. So it breaks off very, like halite does, it breaks off into different cubes. So a lot of them break off very easily along flat sides. The arrangement of atoms help the cleavage. So how they are arranged, it makes them cleave easier. So like mica, which is, let me just get my pen. Mica, which is actually right there and here. When you peel it, it comes off in layers of sheets. It's really cool. Most minerals, though, they fracture, and so they don't necessarily break apart evenly, but they do break apart with flat sides. All right, last thing is like special properties. So a lot of minerals have some special properties to them. So calcite, if you notice right here, it can bend light, and when it bends the light, there'll be a double image inside of it. So you can see that there's a double image of that stem. Some conduct electricity, and some are magnetic. Okay, so how do minerals form? Couple things real quick. A geode, which is a picture right here. Inside of a rock, sometimes you might get minerals and crystals, and the reason why is what a geode is a hollow rock, and mineral crystals form inside from crystallization. So what happened probably was there was a crack in the rock, and some minerals, liquid minerals, dissolved in there. It's like a solution. And what happened is then they start to dry out, and the leftover material is the crystals that you see inside. A couple things real quick. There's 3 different ways that crystals can form, and minerals can form, So they can form organically. Not many do this, very rarely, but some do. Some form from dissolved solutions, kind of like the geode, and from magma/lava. So organically, some ocean animals and clams and corals can make shells out of like mineral calcite. So that can be formed, and then when they die and so forth, those animals leave their shells, and then that can form into minerals. Okay, next, we have is minerals from solutions. So a solution is a mixture of one substance dissolved into another. Elements and compounds dissolved in water that leave a solution, the crystallization occurs. So crystallization will happen. So minerals can form in this way when bodies of water on the Earth's surface, they can evaporate a little bit, and they leave crystals behind. So the solution is water with another dissolved material. So it's usually water. Let's see, evaporation. So minerals from solutions. So evaporation. So when solutions evaporate or dry out, it leaves behind salt crystals. So a couple are gypsum, calcite, and halite. Those are a couple different types of minerals when the solution dries out. And it's next is hot water solutions. So magma can heat water inside the earth, and when the water dissolves from the magma, the water is a solution, and it makes minerals. So quartz, silver, and gold are a few. Next is minerals from magma and lava. A couple things. Hot magma cools inside the crust, so that's inside, and the lava hardens on the outside. That comes out of the volcano. So magma's inside, same stuff. It's just the magma's inside the earth. Lava comes out the outside. So when they cool, they both make crystals, which turn into minerals. So magma is inside and it's deep below the Earth's surface, and it cools very slowly. So when it cools slowly, large crystals are formed inside the mineral. So like quartz, feldspar, and mica, you'll see like large crystals because they are cooling very slowly. Lava, which cools much quicker, is on the outside of the surface. You'll get small crystals, and lucite and silicate are two different kinds. Okay, last page real quick is they're found all over the world, minerals. There's different deposits of minerals are found in certain areas. A deposit is a large quantity of the minerals. Iron ore or large deposits are like pyrite. Pyrite's another one. Magnetite and hematite are different deposits that can be found all across the world. All right, boys and girls. Hopefully you can come to office hours today, and we might be able to play a game, or if not, if I can't find one, then if you have questions and so forth, we could go over your questions. Okay, boys and girls, have a great day.